Hello and welcome to another talk of Alluxio's Data Orchestration Summit 2020. My name is Linden, and I want to talk today with you about how we using Alluxio together with Presto for our data platform. I will share my screen now, and then my name is Linden. I work as chapter lead engineering at Ryte. On this picture, you can see our development team in Vietnam. If you ever wonder why a German guy working for a German software as a service company from Munich and has a team in Vietnam instead of enjoying beer and lederhosen at home, but like to stuck into small traffic issues, this is because since 2017, we also have our own small development center in Ho Chi Minh City. Our learnings about offshore development teams and how is it to relocate to Vietnam would be a nice topic for another talk. But today we're talking about how we build our unified data platform at Ryte, and also how Alluxio helped us with this. Just a quick reminder to give you a context if you don't know. Ryte is a software as a solution a service to optimize your website and online marketing. We are already helped over 1 million users worldwide since 2012, with 70 people on board by end of today. So in case you want to make your online marketing people happy, say our name. This is how a typical dashboard in our software looks like. We show high-level metrics about the technical state of your website, and then you can drill down to analyze and optimize your website to gain more traffic and revenue out of it. So we have mostly analytic types of data workload. Last year, I showed here at the Data Orchestration Summit how Alluxio helped us to get our latency problems under control in our product search success after we had some big issues with AWS S3. In case you missed it, you can see it on YouTube. In the past 12 to 24 months, we developed a lot of new features, and at the same time, we faced some challenges like a lot of other SaaS companies will know if you have multiple products. At one point, our great product owners came up with the idea that combining data of our different products will help us to build even better features out of it. On the other side, as a tech lead and developer, you maybe get a little bit scared if you think about how to combine terabytes of data with an advanced tech stack, different kind of data schemas, and different products at the same time. Back in the days when we looked at it, we found out that we have a quite big tech stack, but overall it's not super different in our case. Our whole infrastructure is running complete on AWS in both main products, website success and search success. So we're using AWS with Terraform as our infrastructure layer. Our data storage in both cases is AWS S3 for our packet files. On top of it, both products are working with Presto, different version of Presto to point out here. And in search success, we already implemented Alluxio, as you can see in my talk from last year, why and how we do it. And on top of it, we're working with Docker for our API layer, and depending on the team, our backend APIs are built in PHP or Scala. So there are some small differences which make it, or can make it quite difficult, but overall our tech stack is not so different. To give you some more context, how we're working with data, this is a very simple diagram to show how our data flow is in our search success product. So, so we have an importing application, which is running a container and importing data on AWS S3. This data is stored as compressed packet files to have a good performance for our analytic workload. These Parquet files are then queried by our Presto and Alluxio stack we are using here to return the results for our API. Our second product is similar but a little bit different. So the main difference here is that we have a bigger post-processing workload before we creating the final data set, which is also Parquet on AWS S3. For this post-processing, we're using Spark, and for querying the data from our API side, so from our customer side, we're also using a Presto stack built on AWS with EMR. As you can see here, this is what I already showed last year. Some feedback from our customer before we implemented Alluxio back in the days. This was a very stressful time because we had these already mentioned latency issues. As I already mentioned, you can get more information about this when you look at our talk from last year. After we implemented Alluxio, everything works super smooth and our customers were happy again. Back in the days, I named Alluxio and Presto as as some kind of messiahs for our use case, which turns out even 12 months later, this is totally true. In case you are not so familiar with the combination of Alluxio and Presto yet, here's some more technical view. So in the end, Alluxio is running side by side with our Presto cluster, and it's caching data from AWS S3 to increase our performance significantly. The benefit of running side by side is here that you have very good allocation of your underlying hardware, and it's very cost efficient. In our case, when we made our benchmarks, with Alluxio, we had our query time reduced by 72% on average, which is amazing. We didn't had any other update of our data backend, which is such a significant benefit. But yeah, let's come back to our problem or our challenge we faced in the last year, that we want to combine our data between our products to gain new features out of it. Here's one real-world example, which we already have released, I would say, end of summer this year. From now on in our search success product, which is mainly about your performance in search engines, like how many clicks, how many impressions you get, we also show you now how many issues you have on your specific website, so that online marketing manager or SEOs can easily see, filter, and analyze where are low-hanging fruits, where they should start optimize, or where very important web pages have significant issues they need to fix. First time when our product owner showed me or showed our team these user stories, I feel a little bit like this, because it was the first time that we need highly integrate between our products on the data layer. This was some immediate immediately some questions came up on this topic. Overall, how do we integrate data between our products? Because we didn't really did this before, especially not with some kind of big data, so gigabyte or terabyte of data we need to use for ad hoc queries. How do we keep our data ownership clear? So means until now, it was very clear which of our teams is owning which kind of data. How do we make sure that this will not get into any problem when teams accessing data from other teams? How do we measure and monitor performance? At the moment when team A is accessing data from team B, it's very crucial that we make sure we didn't have any effect on the performance for other parts of our product. Then how do we handle breaking changes on our data structure? So for example, you have a database table and you add a new column, or you want to remove a column or rename a column. This can now lead to breaking changes, and you need to make sure that the other product is not affected, or at least it's aligned with them and they know this will be happen, and you can then manage this. And overall, how can we build this feature with not over-engineering this MVP? Because as you can see, it's just a few more information we want to add to our data, but with all these topics in mind, we need to make sure that we didn't spend now a half year until we have a first small release, because it's also very important for us to get very fast feedback from our customer side if this feature is useful, if they miss something. So we would really like to have some kind of minimum viable feature before we invest much more effort into maybe complete rebuild or rethink our data structure or data platform. And as often in software development, many roads lead to Rome. I'm not sure if the sentence is known outside of Germany, but this is one sentence we use in Germany. So here's an abstract view of our stack before we started developing this feature. The first idea was that we can maybe use JDBC to query between our Presto clusters. It's quite reliable. We have no access to the underlying data and a proper interface with JDBC. Our table schemas can be seen as some kind of structure contract between our product teams, which are not allowed to break. The big problem here is a big unknown regarding performance, especially when it comes to joining these kind of data. Because to optimize and push down complex operations via JDBC, this is still a big topic and in progress for Presto SQL. The next idea was if we can duplicate the meta information in both clusters and give each of the clusters read access to our other data store. This would maybe bring us the best performance because you access directly the other team's S3 data storage, but it has multiple downsides and can easily lead to data inconsistency. You have no proper interface defined between your teams, and it's easy to break on data schema changes. The next idea was if we can build a central meta store so that both teams keep their data store owned by themselves, but the meta information, therefore the schema information, is shared. This has also some disadvantages because you cannot independently work on your cluster anymore. For example, when it comes to upgrading your Presto stack or similar. It's also difficult to work with multiple S3 buckets in one meta store across different AWS accounts. One of our favorite idea was if we can use a Presto to Presto connector here, but it turns very quick out that this is not an option because it's not yet available. The Presto connector seems to be somewhere on the roadmap, but not for now, and so it was not an option for us to choose from. So what we finally did, we are going here for a two-step approach. For our first minimum viable feature, we used a JDBC connector. So this was, as we found out, very quick to deliver the feature and to gain first feedback from our customer before we make any bigger decisions. What is the best way to merge our data in the future? Here are some learnings when we implemented this. First, it was easy to implement. JDBC is very well known for most developers, so it was not a big effort to put this into our application and put it in our Presto stack, which is more or less just a Presto connector plugin you have to install with some configuration, and then you can access other Presto clusters via JDBC. On the second point is it's low effort for our other team. So it was possible for us that the team who want to implement the feature can go into the lead without high demand of support from our second team. There was some support needed, for example, that we can access the other team's Presto infrastructure, but there was no big feature development necessary. Another one is that we used the schema as some kind of consumer-driven contract. So our team at Search Success was creating some kind of contract, which schema they are expecting, and this is now part of the second team's testing. So it means if the other team would make some breaking changes on the schema, which would make or which lead to a breaking change on our side, this test will fail and they are not able to deploy it on the CI/CD system. To keep the performance impact for both teams under control, we are using Presto resource groups, which means that we can specify that our queries from cluster 1 to cluster B are only allowed to use a specific amount of resources, which keep us stable and which make sure that we don't, or we are not able to shut down or crash the second cluster. After implementing this approach, our product owner was quite happy because we could deliver a very small first version of this feature into the market, and we could gain some first feedback how next iterations could look like. At the same time, we are looking from the tech side, how can we improve this and what is a more or better long-term solution, especially when we integrate also other products in the future, which is which would be very difficult with this kind of JDBC approach. Because we also had a lot of disadvantages, and that's why we named it the long shot. So what can we do as a long-term solution for this kind of workload? Trade-off, as we already mentioned, it's difficult to push down any kind of complex SQL over the second cluster because the current JDBC connector is not able to do it. So that means whenever we're joining data, we more or less transfer a very raw kind of data between the clusters. This could lead to some higher latency if your amount of data is getting too big or your network interfaces are not fast enough. Resource allocation is very hard because we need to keep a lot of unused resources sometimes to keep the performance high. Also, the query performance is not owned. What I mean here is, if we make a query now, this query is in reality are based on two queries. We're making a query on our side of the stack, and we're making a query on the other team's side of the stack, which means that we are not able to optimize, for example, the query performance with Presto configuration because the second cluster is not under our control, which makes sense to keep it to keep ownership clear. But this also means that a part of the performance we are not able to improve independently. All these topics lead us to a more advanced second version, which is to use Alluxio on top of EMR as some kind of data orchestration layer across our different products. So that means we can have multiple data sources, which at the moment in our case is AWS 3, but there will also be other data sources in the future. And on top of Alluxio, we can run different kind of query engines. For example, Presto on ECS on our side and Presto on EMR on other products, or Spark for post-processing, so that each team still keep the independent application layer, but our data access layer is unified and make it very easy for us to manage different kind of data between teams. Of course, this also means that we need to have a very good communication and alignment between our teams, but this is only necessary on a very thin layer, which make it easy to control and which didn't lead us to some of these issues you normally have if you build big monolith infrastructure systems. So this is our second iteration approach, which also has then a clear ownership of query performance, because then we are able to access cross-team data with our query engine, which is Presto, and we are not depending on resources from the other team. Here you can see what are the outcomes and why it works for us. So as I already mentioned multiple times, we have clear ownership. We have a shared data layer, which also lead to optimized costs on top of AWS S3. We have low impact on write operations. No latency impact across our products. We can independent upgrade and configure for individual workloads of our specific products. Which also is a big advantage here. And the trade-off is, or the trade-off we need to take is that we have a shared kind of schema, and this will be managed in our case by consumer-driven contracts, so that each team specify what they expect and to make sure it cannot get broken with any kind of release in the future. What are our key takeaways from this topic? I cannot repeat often enough. Clear ownership of data is important. The same as for infrastructure and software. I think for infrastructure and software, the most teams are already very aware of it, that each part of the application need to have a dedicated owner, like personal team. The same for infrastructure. But this is also important for data, especially when it comes to the topic if you want to duplicate data, because then you need to decide, okay, but who is defining the schema, who is defining changes on the data, etc. So this is something I feel companies should be very aware of when data is one of the key driver for this company or for the product they build. Then another key takeaway is it's maybe very good to go for multiple iterations as we did, so that we first used a very simple approach where we know this will be not a long-term solution, but we already can gain feedback and make then better decision how the bigger infrastructure change will look like. Another learning was that it's also sometimes good to not overcomplicate it. We also discussed about some super big advanced data systems where we can copy the data and have different kind of ETL systems between it to streamline it. But I think what we're doing now is a much more lean approach, which also make us better performing in our feature development, and we try to remove any unnecessary complexity here. And also a key learning was that Alluxio, where I'm anyway a big fan of, can help you managing these kind of data system, because it decouples your pure data storage, which is in our case S3, from your data access, which in our case is Presto, and make it possible that you have a dedicated layer for your data orchestration and management, which then make it much more stressless for you. And the last point is just keep going. And we also trap into some smaller pitfalls all the time and some small learnings. And this is something where you just need to accept that this whole topic of data orchestration is still ongoing. And I have the feeling every week something new come up. Also, Alluxio is shipping continuously new features. So I think it's very important to keep going here, not to think about, okay, I built now something, I don't know, EMR on S3, and this will be my final solution for the next decade. So maybe you need some shorter feedback cycles here to improve. So that's it. That's what we learned. That's what we built in the last year. I'm very happy to be able to show this today. And maybe I can talk about another iteration next year. Let's see. And now I think we have some time left for questions or some notes people want to have. So feel free, whatever you want to ask or mention. Thanks a lot.